When we're at the end, I would just started giving smiley faces for, how would you describe this child? Smiley face. I ran out of adjectives, just leave me alone. I know, you're fine. So, here's what we've got for today. We got calculators and stuff. Alright, so there's three, or really two main ways to lose points on a test, or if we're doing the AP exam, whatever. So, the first one is you need to graph the sample data. The second one is you need to understand that the condition is not about the population. It'll make sense in a minute. Yes, it is about the sample. And I would put an arrow right here and be like, must do this. Yeah, well, luckily, when you have the data, you can put it all in lists, and then you can do it that way. So, when it comes to the large / normal sample, if that condition's not met, this is where you need to actually graph it. So, you have to graph it. There are a couple of different options for how you can graph it. One of them is a dot plot. Another one is box and whisker. Dot plot. Remember how to spell whisker for a second. Alright. So, this is kind of just like the nitty-gritty. You need to actually graph your data to make sure it looks normal, especially if you are below 30 for a sample. Alright, so we have an example. Alright, this is 18 rolls of toilet paper. Alright, so I don't have enough. That's where I have to graph it. Alright, so we need to enter all of this into lists and spreadsheets. So, hang on. Stat, edit. No, not really. You just need to make sure you've got all 18 of them in there. Yep, they're all going in that first list. Not really. You just need to make sure you got all 18 of them in. Alright, so we got 4 steps. First one is do what? Well, yeah, second quit in the calculator. But we did the 4 steps yesterday. State, plan, do, conclude. So, yeah. Alright, so we need to construct a 99% confidence interval for the mean. Alright, and then we're going to do it from data. So step 1 is state. So we are going to run a t-interval. Alright. Step 2 is the plan step. That's where we need to go through and check everything. Alright, so was it random? They said it was random. Yeah, it's just, this is what test I'm going to run in the calculator. So random. Yes. What were the other 2 checks from yesterday? Alright, so is it less than 10% of the population? Yeah, there's a lot of toilet paper in the world. Alright, what's that last one? It was the one from yesterday. It was large counts. So, 18 is not greater than 30. So that's a fail. Now, I'm going to show you how we deal with this. So remember, we said if it fails that, we have to graph it. So do you guys remember how to do a box and whisker plot on here? Second stat plot. I'm going to turn on number 1, and then it's going to be the box plot, and we're going to go to the 4th one, where it gives you dots for which ones it believes are outliers. I'm going to leave it right here. Hang on. Second y equals, or not second y equals. Yeah, second y equals. Okay. The third one's a histogram. So the one on the right will not show you outliers separated from it. They consider the outliers in it. Well, I would like it, because I'm trying to assess normality, I would like you to tell me if there's any outliers. I think it's zoom 9. Circles. All right, so remember to change your window, I think it's zoom stat, which is number 9. Hang on, I gotta turn off. Because I have other crap in the y equals, sorry. So, yours does too. Go to regular y equals and just delete it. That's the bad part about sharing calculators. Yeah, so because this is a frowny face, now we need to graph it. So in looking at that graph, hit zoom 9. Mine's a computer. All right. So, guys, if this is our little number line, if I hit trace, all right, I got a median at 25. I've got Q1 at 23. That whisker goes to 20. That one's at 27. And then the last part for my tail is at 29. Box, few whiskers. Everything seems to be about the same. I don't have like really long whiskers or one shrunken box. So this is where you graph it. This is where we say proceed with caution, looks normal. Because if it wasn't normal, one of the boxes would be like gone. Yeah. So here, I can kind of fudge with it a bit. To the bottom. So if I add in 150 as a data point, that's obviously going to be an outlier. Zoom. See how it shrinks it up and now I got that dot? That's when I know it ain't normal. If you're like, something ain't right. Now I gotta delete that. We haven't gotten to that yet. Zoom. 9. It is. All right, so generally normal. We are going to proceed with caution. All right. Now this next part is we actually have to run our stupid t-interval. All right, so it's stat tests. We said it's going to be a t-interval, so it's going to be number 8. Now, yesterday we did it from statistics, where we had a mean, we had a standard deviation. Today we're going to do data. So, data, whatever you want. Yep. So, data, list 1, frequency is how many of those lists do you want. I never change that. I always leave it as 1. 0.99. T interval. 8. What's really messed up is when I first started teaching statistics, we had a problem, and in the book it said, what do the data tell you? And I was like, that's wrong. What do the data tell you? And, like, I was like, that's wrong. Someone go find an English teacher. We went and found an English teacher, and they were like, technically that's correct, because data is both plural and singular. And I was like, it's just stupid. So we made it a joke of, what do the data tell you? All right, ready to hit enter? You already did? All right. Frequency is just how many of those lists. I never change it. And you guys will never have to change it, so I would leave it. All right, so I've got a confidence interval. So the interval itself, I know, me too, goes between 22.991 and 26.897. All right. So what were they originally doing with all the toilet paper? All right, so they were just trying to absorb the same amount of water each time, just doing it with the same brand, just 18 different rolls. Now, if we really wanted to try this, we could also do it with the brown paper towels that we have in schools, which, let's be honest, tortillas do a better job of actually absorbing water. They literally are. It is such a waste. Just buy regular paper towels. Whatever. That doesn't shock me. Yeah. So, this next part says, how can we choose an appropriate sample size? So, to choose an appropriate sample size, we are going to do T star times S over the square root of N. However, we need the sample size to get degrees of freedom. So that does make life a little difficult. So instead, we pretend to know standard deviation, and we use Z instead. So this becomes Z star S over square root of N. Because the only way for me to find T star on that chart from yesterday was you needed degrees of freedom. No, most of the time they'll be like, if you want to run a confidence interval, like I think this one is, we want to estimate mean. Is this the one? Yeah, this one's walking through how many students need to be sampled. So guess what? We're going to do it. All right, you guys got your blue sheets from yesterday? Your conclusion would just be, we are 99% confident. Yeah, I have it. It's typed. All right, so we got, yeah, because we're not doing a whole crap ton of work. Do you want me to pull up the table as well, so you guys don't have to worry about getting out your own? Okay. That's the problem. We can't find degrees of freedom unless you have the sample size.
Wait, didn't this one have a sample size of 18 rolls?
Yeah, that one did. Where did I put? Not others. I drive. Formula sheets. Pretty sure it's in here. It's trying. Struggling, but it's trying. Alright, so this was the whole table from yesterday. Yes? We remember this? So, Chloe, to answer your question, degrees of freedom, remember, are sample size minus 1. Well, if I'm trying to figure out sample size, I kind of can't find degrees of freedom, can I? Because that's going to make my life difficult. So, that's why we drop it all the way down and we use Z star instead. Because I need N to find degrees of freedom too. All right, so for this one, you come over here, you come here. All right, we are running a 90% confidence interval. All right, 90% confidence level with a margin of error of at most 30 minutes. So plus or minus 30. All right, a pilot study indicated that the standard deviation of the time spent on homework per week is 154 minutes. All right, so this is estimating homework, and it doesn't specify age, does it? Like, I don't know if this is high school, I don't know if this is elementary school, I don't know if it's K-12. If it's K-12, that 154 makes a lot of sense, because little kids shouldn't have homework. At least in my world, they shouldn't. Big kids, sorry, y'all gotta get some stuff done. So, how many students need to be surveyed to go through and get everything? So, we're doing a Z-star, because I don't know sample size, so I have to get a Z-star. I have to go to 90, so that's 1.645. Oh, let's use black. And I'm going to extend this. So, 1.645 times, what's that standard deviation again? 154 over square root of n. And I need that to be no more than 30. Okay, that's my margin of error. Because remember, all of this together should equal your margin of error. That came from the table. That's my Z-star value. So, yes. You back. So, I've got 30. I can divide that by 1.645. And that leaves me with 154 divided by square root of n equals this 18.237. Multiply both sides by square root of n. Divide by that 18.23. So, I'm going to show you a really lazy way of doing this. I know I have to divide 154 by that answer I just got, and I don't necessarily want to round, and I really don't want to type it back in. Second answer. So if you hit second and then the negative button, it'll give you the answer from the last thing you added in. All right? This equals the square root of n. So I can square it. And I get that. Now, if we're trying to write this like as a formula, like instead of writing it this way and having to do the algebra each time, which, by the way, we got n equals 72. We'll just round it up. Cool. 72 people. Yeah, we could do the less than or equal to. Come show them how to do it. No, Kyle found a lazy way to do it. Here, Kyle, you want the mic? Yeah, show them how to do it.
I need the equation.
Go grab it. Mm-hmm. So if you guys hit math, you have to hit the down arrow to scroll. All right, you guys watching this? So, math, and then hit C. No, it's on yours too. Math C. It's the numeric solver. That's okay, hit enter. B is the solver. So it's the last one. Yeah. So what he did was he set it up and solved it. Now, some of the older calculators, yours looks different. It says 0 equals. So for you guys, hit math. Hit the math button. Math. Go all the way down to the bottom. I was going to say, you got video on, so they saw my face. All right, we'll go up here. If you just click up, it's right here.
Oh, it's B?
It's B. So you can just enter it exactly how you see it. So enter the left-hand side over here, and then on this side, just put 30. So for you guys, you're going to have to minus 30 so it equals 0. So on yours,
Wait, what? Hold up.
yes.
Wait, I didn't get.
Hang on. Put that in the wrong spot.
Oh, yeah. I used I got two.
Yeah, you guys can go see Sarge. Jingle.
Maybe it's
You have to go up to where it says X and see where it says solve. You have to hit the graph button.
oh, I don't have that. I'm gonna
Click up.
throw something.
Now click graph. See how that little button popped up now?
How do I click?
You hit that button right there.
I suffered through a